think, or F. Whoever types in first gets to choose which letter.
Which one's the hardest one?
Which one do I not like the look of the most? To be honest, they're all not too bad. They're pretty straightforward. I think F, just because it's the last one, would probably spook people more. Or you've got E, which has, actually, let's go for E, because it's got a combination of different things. So we've got the function x, which is 1 over t minus 2, and the function y, which is t squared, and it's defined for t is greater than 2. We've got to find a Cartesian equation, the range, and the domain. Let's go for the Cartesian equation first. And there are a couple of ways of going around it. If you really can't spot a way to rearrange so that you can drop the x variable into the y, which is what most people would look to do. So you rearrange x so that it is t equals something of x, and then drop that into your y equation. If you can't easily see how to do that, remember one thing, that you can do the other way and change t into some function of y and drop that into x. That is still a Cartesian equation. It may not quite get all marks, but if you haven't been able to spot this way round, you'll probably get some marks for this, because it is actually created. You're showing the understanding of what you need to do, and is strictly correct. It's just whether or not you can use it later, or is it usable in our form. This basically means that if you're doing integrations and differentiations, rather than integrating with respect to x, you'd wind up doing things in terms of y, which is on the vertical axis, which could cause some problems with integration questions. But do those. Okay? Try that one first, because that's the one we prefer. But this one is worthwhile afterwards. So we want to write x in terms of t. So t is the subject. So we get 1 over x is t minus 2. And t is x, 1 over x plus 2. What we then do is we then put it into the equation y. Y equals, instead of t, we're now writing this expression, 1 over x plus 2 squared. And that should be sufficient. You don't have to multiply it out. It will keep it reasonably straightforward. Okay, so that's how you can write that as a Cartesian equation. I wouldn't expand it out even. That's probably what I would expect to be the answer for that one. We'll check it in a minute. So that was part 1. Part 2, they want to know the domain. So the domain is what is happening for this function for the various values of x. So if we stake t at its minimum, so t is greater than 2, we put that into the equation. Because this is greater than, we do not include the result for x. So this actually means that we are going to do either something less than or greater than strictly. There is no equals in it. Okay, so the equals part, not in this equation, or for this one. So I put the 2, we now try when t equals 2 to find the limit. And so we get x is equal to 1 over 2 minus 2, which leads to that being infinite. So that tells us that we are going up to infinity. Try when t, now it's saying t is less than infinity, so we're going to try t at being very large, or infinite. So we're doing the limit as t goes to infinity x equals 1 over a very large number, and this comes down to being approaching 0. Notice it limits towards 0. It will not exactly be 0 because we're only getting a limit. So x must be between 0 and infinity. That's what that statement's saying. Because we had to take a limit to find this x value, we have to find out what values is it, does it go up to or does it go down to. One other thing to check, it's not a problem in this, shouldn't be a problem in this one, is what happens with dx dt and what happens when we differentiate 1 over t minus 2. Let's do a u. Differentiating 1 over u gives me the log. Hopefully you'll recognize this fairly quickly as this becomes out as the log of the function on the bottom. So you can do it by chain rule, or we can do it by a function over a function. Differential. What am I doing? I fell into the trap again. So u equals 2 minus t, du dt is 1. So we can do the chain rule of u to the minus 1 differentiated with respect to u, and du dt is just 1, which gives me minus u squared, so minus 1 over t minus 2 squared. Can we ever make this equal to 0? No, because we've got minus 1 on the left hand side, and when we multiply that up we get minus 1 equals 0. There is no other minimum or max. So in the book they wouldn't show you that step. I don't think you'll see that in the exercise book or their worked answers. They will purely go on the basis that this is a linear or an inverse function, and as long as you're not saying t equals 2, we know what values it is valid for. But for completeness, this would be a proof. So we can now say the domain, we've got here saying it goes up to infinity. This one said on the bottom end, so for t at the smallest value, x must be 0, but we never get there because of that greater than. We never get to 0, which is x. So more traditionally, x is greater than 0 on my domain. Number 3, they want the range. And again, we're doing t is greater than 2 for y equals t squared. T is t squared, yeah? Yep. So my range of functions are when t equals 0, this is a limiting value, it is not part of the group. So limiting, we get try t equals 2, sorry. And we get y equals 2 squared, which is 4. Try it at its top end, t, as t goes to infinity. This goes up to y becomes infinity squared, which is infinite still. Excuse me. So we're now showing that y is between the values of 4 and infinity, never gets to infinity. And because this 2 is not part of that group, we never get down to the 4 either. So y is strictly greater than 4. Let's have a look and see. And by rights I should actually check, is there another value of t that might give me a smaller value than this 4? So dy dt is 2t. We set this value equal to 0, so a minimum point that we need to check is 2t equals 0. So t equals 0. If we look at the definition of the domain says y is strictly, wish I hadn't put the white mark underneath it. we go. So t is strictly greater than 2. So this minimum point doesn't matter in our equation. So this is not in the domain for t greater than 2. So my range is strictly the y is greater than 4 that I wrote above. I'll just copy that below. Those are the bits that we've got. Let's just see, can I do it that way? Come on, let me edit it. So what did we have for the x function? My x function is 1 over t minus 2. My y part of it is t squared. We are doing a range for t from 2 and not including it up to a very large number. So these are my values that the function's drawing for. That's what the graph shows. It's showing me all points x greater than 0, which is my domain. It's purely defined on the right hand side. Doesn't matter how far out I come. There's no yellow part on this side. If there were, you'd get, if we had, we'd get a gold line where that grey A is now. And as we go up, we're now getting our values. So strangely enough, the values are going the other way to what you would normally expect. And the range is going above 4. There's no way, by bringing this t down, that I can get a value less than 4 without going negative. I was trying to do this yesterday as well. Couldn't get it to move just 0.1 there. 2 is undefined.
Sorry, were you showing a graph?
Why am I showing a graph? Is that, or are you saying, am I showing?
No, we can't see.
Oh.
Yeah, are you showing a graph?
Yeah, I'm showing the graph. I'll just show you the whole screen. That graph. See the graph. It's purely the gold bit. As I pull out, there's no more bits defined on this left-hand side or the right-hand side. And when I choose the value 2, it disappears off to the right here. As I get slightly bigger, we get onto our graph and it follows all the way round, giving me more and more numbers. And if I make this negative below my value of 2, we now start getting these points over here that the graph hasn't drawn yet. And that's because I told it to do strictly from 2 upwards. Right, I'll just have a quick check and make sure I haven't messed up any answers. Question exercise 3 and that 3A, part 3, part 1. Oh, that's prior knowledge check, that's why. DDE. Yeah, they're saying y equals, oh, they multiplied the bracket out. They've multiplied out that bracket. They said that they agree with our domain, they agree with our range, but they've multiplied out the bracket in here for some reason. Sometimes they do, sometimes they don't, but they've just rearranged this to give us a common denominator. Actually, they've just put this over a common denominator inside the fraction. So we've got 1. To get it all over x, they've done plus 2x squared. And that's their answers as well. All right.
And you chose 0 as the minimum because
I actually
doing...
calculated. They chose 0 minimum. X is minimum when t is at its minimum value, and the smallest value that we're not allowed, or the biggest value we're not allowed, is t is 2. So we calculate what happens when t is 2 to x. X disappears off to infinity. And when t is very large in my equation, what happens? And we get 0. Because if you notice, as my t gets bigger, look where the x value comes to. The x value is getting closer and closer to y equals 0. Ah, get off. Why has it done that? So as I make my t value bigger, it's getting closer and closer to x is 0. Yeah? And that's what I did here. With t gets very large, the limit as t goes to infinity is 1 over infinity minus 2 is still infinity. So 1 over infinity is 0. So it's getting closer and closer to 0, which is what that's showing there. So it's still up here at 0.125.
Oh, okay. Okay.
Yeah. So that's why we're looking at these numbers. It sort of gets glossed over in the book, and I'd like you to be a little bit more rigorous, because I think they want more rigor in the exam than they've shown in that book. Because that's one of the big things with P4 is they get a lot more stringent about how answers should be given. Okay. Do you need another one, or are you happy as if we are at the moment?